Okay, so here we have a question. A piston P in a machine moves in a straight line with simple harmonic motion about a point O, which is the center of the oscillations. The period of the oscillations is 3.142 seconds. When P is 0.5 meters from O, its speed is 2.4 meters per second. Find the amplitude of the motion, the maximum speed of P during the motion, the maximum magnitude of the acceleration of P during the motion, and the total time in seconds to 2 decimal places in each complete oscillation for which the speed P is greater than 2.4 meters per second. So total 11 marks. So we've got the period as 3.142 seconds. We know that omega equals 2 pi f, and we know that f is 1 over t. So omega equals 2 pi divided by t, and you know that t is 3.142, so you have 2 times pi divided by 3.142, and that is about 2. And then you use the equation v squared equals omega squared brackets a squared minus x squared close brackets. You know that in the question v is 2.4. We've worked out omega is 2. We need to work out a, but we're given x as 0.5, so putting all of those in, you get 2.4 squared equals 2 squared brackets a squared minus 0.5 squared. You divide both sides by 4, 2 squared, so you get to 1.44 equals brackets a squared minus 0.25. 0.25 is 0.5 squared, and then you end up with a squared equals 1.69. Square root that, you get a equals 1.3 meters. So 1.3 meters is the amplitude of the motion. What is the maximum speed of P during the motion? So that is using the equation V equals A omega. You've worked out A is 1.3, omega is 2, so V is equal to 2.6 meters per second. Part C, the maximum magnitude of the acceleration of P during the motion. So the equation for SHM, A is equal to minus omega squared x, where A is the acceleration, omega is the angular velocity, and x is the displacement. So we've worked out omega was 2, and x is the maximum displacement. In this case, it's amplitude. So it is minus 2 squared times 1.3, and you get 5.2. Now for the next question, there are 2 ways of working out the total time. So let's use cos. So if we use x is equal to a cos omega t, now here what we're trying to find out is the difference between the 2 times. So what we're trying to do here, because the maximum speed is here, right? This is the maximum speed, and 2.4, let's just say it's here, I'm not doing it to scale. So here's 2.4, here is 2.4, and we're working out the bits in the middle here. So because the question is asking for the greater than 2.4, so here it is 2.4, and here is also 2.4. So here's 2.4. So here we're trying to work out the times between here. So we just need to work out the time here and the time here, and then we work out the difference and then divide by 2. Okay, so the time when it is at 2.4, the first time is when it is 0.588 seconds. Now we need to do the negative of the displacement, because now it's on the other side. So now you have minus 0.3846 equals cos 2t, and the time in this case is 0.983 seconds. So the time when it reaches 2.4 and it goes through the equilibrium position and it goes back to 2.4, so the time between those 2 points will be 0.983 minus 0.588. Now because it's an oscillation and it's symmetrical in both directions, you times that by 2. So you get the total time is 2 times brackets 0.983 minus 0.588 close brackets, and you end up with 0.79 seconds. Alternatively, you can use a sine omega t. So here, if you use a sine omega t, if you just work out, because here the speed is 2.6, the maximum speed here is 2.6, and then it reaches 2.4. All you need to work out is the time taken to reach 2.4 and then times it by 4. Because when you're using sine omega t, you're using the reference, you're starting at the equilibrium position. So you just need to work at the time to reach 2.4 and then times it by 4, because you have where it says 2, 3, 4. Those are the times when it is greater than 2.4 meters per second. And you end up with getting the same as 0.79.